Welcome to another deep dive here on the show. Today we're going to tackle a pretty huge topic.
Yeah.
The eventual fate of matter itself.
Big one.
You want to know if all matter eventually decays.
Mm-hmm.
And to get to the bottom of this, we've got answers and explanations from an AI that is very knowledgeable about physics and cosmology.
Feels good to me.
So we'll be going through all of that today.
Right.
We're going to uncover the science behind matter's decay, explore the crazy timescales involved, and even touch on what all of this means for the future of life in the universe.
It's a pretty ambitious question, and we'll need to cover a lot of ground even just to start answering it.
It definitely is. But that's what these deep dives are for, right?
I think so.
To get into the weeds.
Yeah, get into the weeds.
So we all know that some matter decays, right? Things like free neutrons, radioactive atoms, those are unstable, breaking down over time.
Right.
And they each have a specific half-life, which is the time it takes for half of the original matter to disappear.
That's right. But what's really interesting is that even protons,
Okay.
the particles at the heart of every atom, are theorized to decay.
Oh.
The catch is the estimated half-life is incredibly long.
Okay.
Something like 10 to the power of 34 years or more.
That's way longer than the universe has even existed.
Yeah, it is.
So nobody has actually seen a proton decay?
Right.
It's still a mystery for physicists to solve.
It is one of those big mysteries physicists are still trying to solve.
Yeah.
But if you ask protons decay,
Right.
then that brings us to the concept of heat death.
Heat death? That doesn't sound very pleasant.
No, it doesn't.
Is it what it sounds like?
In essence, yes.
Okay.
It's the scenario where even the longest-lived particles eventually break down.
Wow.
Even black holes, which are like cosmic vacuum cleaners,
Right.
they slowly evaporate through a process called Hawking radiation.
So the universe is slowly winding down,
Uh-huh.
becoming this vast, lukewarm sea of... well, what exactly?
Mostly radiation,
Okay.
like photons and possibly other fundamental particles that don't decay.
Hold on. Doesn't quantum mechanics have something to say about all this?
Yes, it does.
I read somewhere that new matter can be created, too.
Yeah, you're absolutely right.
Okay.
Quantum mechanics offers a glimmer of hope here.
Okay.
Processes like pair production, where high-energy photons transform into particle-antiparticle pairs, show that matter can be created from pure energy.
Oh, wow. So it can be created from energy.
Yes. And then there's quantum fluctuations,
Okay.
with particles popping in and out of existence in the vacuum of space.
So it's like this constant dance of creation and annihilation.
Yeah.
A cosmic party at the subatomic level.
You could say that.
Crazy.
But we need to remember that most of this new matter is extremely short-lived.
Right.
These virtual particles, they're only around for tiny fractions of a second.
Oh, wow.
They appear,
Right.
make a splash at the party, and then vanish.
So even in the seeming emptiness of space, there's a lot happening at that level.
A lot happening at the quantum level.
Okay, that makes sense. But, thinking about all this decay, it makes me think about the energy released in the process.
Okay.
It can't just disappear.
Right.
Like, where does it go?
Yeah, you're thinking about the law of conservation of energy.
Yeah.
And you're right. That definitely applies on a cosmic scale.
Okay.
The energy released during decay gets transformed.
So it becomes something else?
Right. It might become radiation, like photons
Yeah.
or kinetic energy transferred to the newly created particles.
Even though individual particles might be breaking down, the energy's still out there, right? Still doing its thing.
Exactly. And ultimately, all that energy contributes to the overall heat-death equilibrium.
Okay.
But we need to remember there's another factor we need to account for.
No, what's that?
The expansion of the universe.
Right.
The universe is constantly growing
It's getting bigger. Yeah.
and more spread out.
So how does that affect the energy?
Well, even though energy is conserved, the expansion makes it less usable over time
Okay.
through a process called redshift.
Redshift.
Imagine a really strong drink
Okay.
being diluted with more and more water.
Yeah.
The total amount of liquid stays the same, but the drink becomes weaker.
Right. It's less potent.
The energy is still there.
Yeah.
It's just spread out over this vast and expanding space.
The energy is getting diluted, less concentrated.
Right.
That makes sense.
Hey.
But here's a question that I've been thinking about.
Okay.
You described this future
Uh-huh.
where matter decays, but radiation, like photons, continues to exist.
Okay.
But radiation is energy, right?
It is.
So how can energy exist without matter?
That's a great question.
Yeah.
I think it highlights a common misconception about energy.
Okay.
You see, energy isn't simply about the potential differences between objects.
Wait, really? That's what they taught us in school?
Yeah, no, but it's a simplification.
Okay.
That works in a lot of situations,
Okay.
but not all the time.
Gotcha.
Think about a single photon
Okay.
traveling through space.
Yeah.
That photon has energy, and that energy is based on its frequency.
Okay.
And this is captured in the equation EF,
Okay.
where E is energy, H is Planck's constant, and F is frequency.
So a single photon just zipping through space has energy,
Yes.
even if it's not interacting with anything else.
That is exactly right.
Wow. Okay.
And here's another interesting detail.
Okay.
Even though photons don't usually interact with each other, they can under extreme conditions,
What kind of conditions?
like incredibly high energies or super strong gravitational fields.
Okay.
In those situations, photons can actually interact through virtual particles,
Yeah.
creating all sorts of exotic effects.
So even in a far future universe where most matter has decayed, there's still potential for something to happen.
Absolutely.
Wow.
We're talking about timescales that are so vast,
Right.
it's almost impossible to imagine what might unfold.
Yeah.
But the laws of physics, at least as we understand them now,
Yeah.
suggest that there's always potential for change, for something new to emerge.
This is amazing.
Yeah.
It really makes me think, what if we zoom in from the cosmic scale to the atomic level?
Okay.
Like, what would happen if a single oxygen atom in a water molecule just suddenly decayed?
That is a very interesting thought experiment.
Yeah.
First, we need to remember
Okay.
that the oxygen isotopes in water are incredibly stable.
Okay.
They don't just spontaneously decay.
Right.
But for our thought experiment,
Yeah.
let's imagine that one did.
Okay, so this oxygen atom in a water molecule decides it's done and poofs out of existence.
Yeah.
What happens next?
Okay, well, the oxygen atom's nucleus is made up of protons and neutrons.
Right.
If one of those particles decayed, the entire nucleus would transform.
Oh, wow.
And it would likely turn into a different element.
Okay.
For example, through beta decay, the oxygen could change into fluorine.
Okay, so we've lost our oxygen atom.
Right.
Now we have fluorine. What about the rest of the water molecule? Yeah. Those two hydrogen atoms that were with the oxygen?
Well, the bonds that were holding the oxygen to those hydrogen atoms would instantly break.
Okay.
The water molecule, as we know it, would cease to exist.
So it's like a tiny little atomic explosion.
You could say that
Wow.
there would be a release of energy,
Okay.
potentially in the form of radiation or kinetic energy from the new particles.
So this is a very unlikely scenario,
Highly unlikely.
but a very interesting one.
It is.
Okay, I'm trying to wrap my head around all this.
Yeah.
You know, stars dying,
Right.
protons maybe decaying, black holes evaporating, and these events are all on these insane time scales.
Yeah, they are.
But let's think about life.
Okay.
Like, how long until matter becomes too unstable for life to exist?
That's a great question.
Is there a deadline for biology?
That's a good question.
Like, in the universe, when does the music stop?
Well, to answer that, let's lay out a potential timeline of threats.
Okay.
But of course, this is all based on our current understanding of physics,
Right.
which is always evolving.
Of course.
So the first hurdle we run into is about 10 to the power of 12 years.
Okay.
That's 1 trillion years.
1 trillion years? Wow.
Most stars will have burned out.
Okay.
That's the end of star formation,
Wow.
as we know it.
So no more starlight.
Basically,
No more stellar nurseries.
not as we know it.
That's pretty bad for life, I imagine.
It is.
Without the stars, we're in trouble.
Yeah, without stars as energy sources, life, as we understand it, becomes really improbable.
Oh.
But it could get worse.
Oh, no.
As we move into the mid-future, around 10 to the power of 15 to 20 years,
Okay.
planets themselves might start breaking down.
Wow. Breaking down.
Yeah, you remember those interstellar collisions we talked about?
Right.
And the gradual decay of matter into its fundamental particles?
Planets crumbling apart.
Yeah.
That's a bad day for life.
Yeah, it is.
So what happens after that?
Well, then we get to the really long-term future, 10 to the power of 34 to 40 years.
Right.
This is where that proton decay comes into play.
Okay.
If protons do decay, all normal matter will eventually be dismantled.
No more atoms, no more molecules.
Pretty much.
Pretty much game over for anything resembling life.
It seems that way.
And then as a final blow,
Yes.
around 10 to the power of 100 years, black holes themselves evaporate.
Right.
And we reach that heat death we talked about.
Exactly.
With only radiation left over.
And maybe a few superstable particles.
Wow.
but that's pretty much it.
So it seems like life as we know it
Yeah.
will be impossible.
Yeah.
Long before matter completely decays.
Right.
The clock is ticking.
It is.
And it seems to be ticking pretty fast.
Yeah, on a cosmic scale.
On a cosmic scale, that's for sure.
Mm-hmm.
But let's shift gears a little bit.
Okay.
How long does humanity have to become a multisolar species?
Oh, that's a good question.
You know, spread out beyond our solar system
Okay.
before things get dicey right here at home.
Yeah, that's the million-dollar question.
How much time do we have?
So, in about 1 billion years,
Okay.
the sun's brightness will increase a lot,
Okay.
and Earth will probably get too hot for life.
1 billion years.
It's not a lot of time.
We gotta pack our bags.
On a cosmic scale, no.
That's for sure.
And then it gets worse in 5 billion years.
Oh, great.
The sun will enter its red giant phase.
Oh, great.
It's going to swell up dramatically
Okay.
and either engulf the inner planets,
Including us.
yeah, including Earth, or at least scorch them to a crisp.
Not a very pleasant way to go.
It's not.
And then around 7 billion years from now,
Yeah,
the sun will collapse into a white dwarf.
exactly.
So our solar system will be completely lifeless.
Yeah.
So humanity has about 1 billion years
Okay.
to figure out interstellar travel.
It seems that way.
It's a lot to process
It is a lot to consider, but it also underscores the potential we have.
as a species.
Yes, we have the capacity to understand the universe, to develop technology, and maybe even spread life beyond this planet.
It's all about perspective, isn't it?
Yes, we have this challenge, but it's also a huge opportunity.
Okay, so we've laid out the timeline,
Yeah,
the ultimate fate of matter,
right.
and this hard deadline facing humanity. But what are the chances that we'll even survive that long?
Yeah.
I mean, 1 billion years is a really long time.
You're absolutely right. 1 billion years is an almost incomprehensible amount of time.
Yeah,
And trying to predict what will happen over that period is almost impossible.
right.
But we can look at different scientific perspectives and models
Okay.
to get a sense of the possibilities
Yeah.
and maybe even glean some insights
Sure.
into how to improve our chances.
I'm ready to take a deeper look
Let's do it.
into the potential futures for humanity.
All right, let's go.
Yeah.
So how do we even begin to assess humanity's chances of long-term survival?
Yeah, it's really hard to wrap your head around that kind of timescale. I mean, just thinking about the changes humanity has gone through in the last few thousand years is mind-boggling enough.
Exactly. And trying to project that forward 1 billion years is full of uncertainty.
Yeah.
But there are researchers who study this.
Oh, really? People whose job is to think about the end of the world.
Yeah, it might sound a little gloomy,
Yeah.
but it's a really important field. It's called existential risk studies.
Existential risk studies.
And researchers in this field analyze those probabilities of various threats to human existence.
Okay. So, like what?
They look at things like nuclear war,
Oh, wow.
climate change,
Yeah.
runaway AI,
Okay.
even asteroid impacts.
So, quantifying the chances of us wiping ourselves out.
Kind of, yeah.
Wow.
And their work can be helpful in understanding those challenges and how to mitigate them.
Okay.
Researchers like Nick Bostrom have developed models that estimate the chances of these events happening within the next 1,000 years.
1,000 years.
Yeah.
That's still such a short amount of time compared to the billion years we're dealing with here.
Right.
Are there any models or frameworks that look at the really long term?
There are. That's where the Kardashev scale comes in.
Oh, yeah. I've heard of that.
It was proposed by the Soviet astronomer Nikolai Kardashev,
Mm-hmm.
and it categorizes civilizations based on their energy consumption.
Oh, it goes from type I, harnessing all of a planet's energy,
Yeah.
to type 2, using all of a star's energy,
Yes.
and then type 3, controlling the energy of a whole galaxy.
You get it.
That's some serious cosmic power.
Now imagine if humanity got to type I status.
Yeah.
Our chances of survival would go way up.
Oh, wow.
We have access to a ton of energy, allowing us to mitigate a lot of existential risks.
Okay.
We could deflect asteroids, control the climate, maybe even colonize other planets.
So type I is like a major step towards cosmic security.
I think you could say that.
Wow.
But we have to remember
Okay.
that the transition to a type I civilization isn't going to be easy.
Right.
It involves overcoming a ton of technological and societal challenges. And there's always a risk of self-destruction along the way.
We got to be careful not to blow ourselves up before we reach type.
Exactly.
That would be a bummer.
And just to make this more complex,
Oh, great. More complex.
it's something called the doomsday argument.
Doomsday argument. That sounds ominous.
It is a very fascinating, if controversial, idea.
Okay.
Essentially, It suggests that, statistically, humanity might already be in the middle of its lifespan.
Wait, so we're past our prime.
It's a very speculative idea.
Yeah.
And there are criticisms of the doomsday argument.
Okay.
But it raises some interesting questions about how we think about time and probability.
Okay.
It really underscores the uncertainty in predicting the future of humanity.
Yeah, it's definitely a lot to think about.
It is.
Okay, so we've looked at existential risks, the potential for becoming a super advanced civilization.
Yes.
And even the idea that we might be closer to the end than the beginning. Is humanity doomed?
I mean, no one knows for sure. The future is unpredictable.
That's for sure.
But I think there's reason to hope.
Okay.
I think that by managing risk,
Okay.
advancing technology responsibly, and fostering global cooperation, we can really improve our chances of not only surviving,
Okay.
but thriving.
So it's not all doom and gloom.
Not at all.
That's good.
We have the power to shape our own destiny.
Yeah.
And that's a responsibility we shouldn't take lightly.
Absolutely. Well said.
Thank you.
Okay, we've covered a lot today.
Yeah.
From the decay of matter to the potential for humanity's long-term survival. But before we wrap up this deep dive,
Okay.
there's one elephant in the room we need to address.
I think I know where you're going with this.
Climate change.
Yeah.
Our listener is understandably concerned about the possibility of it leading to human extinction.
Right.
It's a very real danger.
It is.
And it's easy to feel overwhelmed by it.
It is a valid concern.
Yeah.
And the climate crisis is a huge threat to humanity. However, it's unlikely to cause total human extinction in the next few centuries.
Okay, that's a little reassuring.
Yeah.
But I'm guessing there are caveats.
Of course.
Okay.
While climate change itself may not cause total extinction,
Yeah.
it can amplify other risks and lead to some really bad consequences for civilization.
A threat multiplier.
Yeah, you could say that.
So what kind of consequences are we talking about?
Okay, imagine more frequent extreme weather events.
Okay.
Rising sea levels that threaten coastal communities,
Right.
widespread ecosystem loss that impacts biodiversity and food security,
Yeah.
increased migration and resource conflicts,
Wow.
and major economic disruptions.
It's not a very nice picture.
No, but it's not inevitable.
That's good.
We have the ability to adapt
Mm-hmm.
and to innovate
Okay.
and to implement solutions,
Okay.
both technological and social.
So there's a choice to make.
Yeah.
Between this path that leads to potentially catastrophic consequences
Yes.
and a different path.
Yeah, a different path that prioritizes sustainability, resilience, and a shared future.
The future is in our hands.
It is.
Okay, so
Yeah.
speaking of the future,
Oh.
let's talk about the human population.
Right.
How might climate change impact the number of people on Earth by 2100?
That's a hard question to answer.
It's a complex one.
It's hard to predict exact numbers because there's so much interplay between the climate, society, the economy, and technology.
Yeah.
But I can give you some insights.
Okay, let's hear them.
First, even without climate change,
Yeah.
the rate of population growth is already slowing down.
Okay.
The UN projects that the global population will peak sometime this century, and then it will start to decline.
So we're not looking at exponential growth forever.
No, demographics are shifting and the growth rate is decreasing.
Okay.
But climate change could change this.
In what way?
Climate change will probably slow down population growth even more,
Okay.
especially in developing nations.
Because they're more vulnerable to the effects. So fewer people being born because of harsher conditions.
It is a possibility, yeah.
Okay.
Think about things like reduced agricultural yields,
Okay.
water scarcity, increased disease,
Right.
and displacement from extreme weather.
Yeah, all of those things would lower birth rates.
Potentially,
Okay.
and maybe even increase death rates.
That makes sense, but wouldn't people just move?
You're right. That's an important point.
Yeah.
It's likely we will see regional differences in population trends.
Okay.
Some areas might see declines due to climate hardship,
Yeah.
and others that are less affected might actually see growth from migration.
So a kind of climate-driven reshuffling of humanity.
Yeah, that's one way to put it.
Huh.
And the exact numbers are super hard to predict
Right.
because it depends on so many factors, like
Yeah.
how severe climate change gets, our mitigation and adaptation efforts,
Okay.
and the policies governments put in place to manage things like migration and resources.
Still a lot of unknowns.
Yeah, a lot of unknowns.
But it's clear that climate change is going to have a big impact on human population.
Yes, in the coming decades, for sure.
It's just another layer of complexity in the future of humanity.
It is.
It's like we're zooming in and out of this cosmic movie from the smallest particles to the largest structures, and it's all connected.
It really is.
What an incredible and humbling thought.
It is.
It brings us back to that question we started with.
Oh, yeah.
Does all matter eventually decay?
The question that launched this whole deep dive.
After exploring all these different things, what's the answer?
Well, like we talked about,
Yeah.
current science suggests that, yes, all matter probably decays on some time scale.
Even though it's a really long time scale.
Yeah, probably longer than the current age of the universe.
Wow.
But we also learned that new matter can be created, even if it is short-lived.
Yeah.
And the energy from decay doesn't just disappear.
Right.
It transforms and contributes to the overall entropy of the universe. We also talked about the expansion of the universe.
Yeah.
And how that makes energy less usable over time.
It's like diluting a drink.
Exactly.
Okay.
We even talked about what would happen if an oxygen atom in a water molecule decayed.
Yeah. And it's not good for the water molecule.
No, it's not.
But it was a fun thought experiment.
It was.
Then we looked at the timeline for life in the universe.
Yes.
And it seems like life as we know it has a limited window.
Yes, a limited window of opportunity.
And it's closing faster than we realize.
That's true.
That's pretty scary.
It really underscores how important it is to appreciate right now.
Yeah.
This time when life is flourishing on Earth.
Yeah.
And that we need to use our time wisely.
Yeah. To address the challenges we face.
Exactly.
It's a good reminder that the future isn't set in stone. We have the power to make choices that affect not only us, but the future of life itself.
I agree.
Well, before we get too philosophical, are you ready for our final thoughts?
I am. Let's give our listeners something to ponder.
Yeah.
Something to spark their imagination and inspire them to explore the universe.
Okay, so what if humanity actually becomes a multisolar species?
Wow.
What if we spread beyond our solar system and make a home among the stars?
That's a huge what if.
Yeah, it's a big one.
It's hard to imagine what that would even look like.
It's hard to imagine.
But it raises some really interesting questions.
I think so.
What responsibilities would we have to the universe?
Oh, interesting.
To matter, to energy.
Yeah.
We can barely manage things on Earth.
It's a humbling thought.
It is.
Would we have to preserve life on other planets?
Oh, interesting.
Protect ecosystems?
Yeah.
Ensure the continued evolution of intelligence?
Wow.
Across the universe?
It's like suddenly we're not just worried about saving the whales, we're worried about entire galaxies.
That's right.
Wow.
It's a huge leap.
It is.
But maybe it's about recognizing the value of all matter and energy in the universe and acting in a way that honors that. So a cosmic ethic.
You could say that.
A whole new way of thinking about our place in the universe.
And our responsibility to it.
That's incredible.
And I think it's something we need to think about.
Yeah.
If we ever want to be a multisolar species.
These are important conversations to have.
Yes.
Even though it seems so far off.
Even if it is far off.
It's easy to get caught up in the day-to-day here.
Yeah, and lose sight of the big picture.
Right.
But maybe by thinking about these big questions, the vastness of the universe, the eventual fate of matter, we can gain a new perspective.
On our own lives and our place in the universe.
Absolutely. And maybe that will help us make wiser choices.
I hope so.
Not only for ourselves, but for the future of life everywhere.
That'd be great.
Well, I think it's time to wrap up this incredible deep dive.
It has been an incredible journey.
We've talked about everything from decaying protons to the heat death of the universe, the potential for new matter creation.
The challenges of becoming a multisolar species.
You said it.
It's been quite the ride.
It has.
I want to thank our listener for the question.
It was a great question.
It's given us a lot to think about.
Yes, it has.
And thanks to you for joining us.
Thanks for having me.
On this deep dive into the nature of reality.
Absolutely.
I hope you learned something new.
I hope so too.
And that you'll continue to explore the universe with us.
Keep looking up.
Until next time, keep looking up, keep asking those big questions, and keep diving deep.